In this video, we're going to do a demonstration of how our cVu, cStor, and cClear, a range of observability and security observability tools, are able to detect network exfiltration events happening within your data center or within your AI cluster. So our network is very simple. We have a client that is connecting through our internet connection into our AI task server. And what we're doing is we're looking for any data that is being extracted from our data model or from the cluster itself. So really we're looking for any type of file transfer that is outside the normal criteria or window or destination from our data center. So with that in mind, what we can actually do is to look at all the traffic coming in and out of our server at full line rate and do inspection and characterization of the class of traffic that is, and we can then monitor that and break that down into our endpoints and the size and the amount of data that is being transferred throughout our network. So what I'm going to do is I'm going to start an extraction of data from our network, and we'll start pulling data and extracting it from our AI cluster. And what we'll see is an update in our endpoint to reflect that the fact that there is now more data being pulled out continually from the network. So we'll see an update in a few seconds telling us that there has been an increase in data extraction, and you can see now we have a new endpoint that has arrived. So this endpoint now has started pulling large quantities of data. So I can now click on that endpoint and look at the download, and I can now see exactly what's going on. So we have the data, and we can now start to see data being transferred from that system. So here we now have the data has started. We're now pulling in the metrics, the metadata of how much data, how long it's been transferring data for, and it will keep a running total of the amount of data. So we can see the instantaneous amount of data that's being transferred and the running total. And we can set thresholds for how much data that we want to detect and trigger on within the system. So here we can set up a 4 GB or 5 GB or however much we need. We can detect when that threshold has been exceeded, and once that has triggered, we can then send a notification to our dashboard and to our alert engine telling us the amount of data has exceeded the threshold, and that we can now trigger that event and send that notification to third party. So what we can now do is we can go to our third-party system, and that notification can be an email, it can be a text message, but we can, in this particular case, we're going to send a notification to our third-party integration with Datadog. So what I can do is I can open my Datadog dashboard, I can go to my service management and my incident list, and I can do a search now, for example, for the last 5 minutes, and I can see now we have an exfiltration event has happened from my AI cluster. That has been outstanding now for about 15 seconds. I can open that incident now and see all the information. I can see when it was declared. I can see what information is telling me about that. I can get access to the dashboard, and I can also hit the download the PCAP file to download that to the local machine, so that I can then investigate which is the client that's trying to access the data. I can reverse that and find maybe the user ID. On top of that, I can also figure out which server they're pulling the data from and the protocol that's being used. Additionally, I can add in our integration with ServiceNow, and again I can open up my incident table in ServiceNow, and I can see again I have an extraction event has been detected, and I can now open that extraction event. I get all the same information that I have the integration with Datadog, again allowing me to root cause the problem, identify exactly which client and which server and which protocols are being used to extract that data. So that concludes our demonstration of data exfiltration in AI cluster using the cPacket's range of network and security observation tools.